Top 25 Kubernetes Interview Questions and Answers. In the rapidly evolving world of cloud computing, Kubernetes has emerged as a vital tool for container orchestration. This video will present a curated list of the top 25 interview questions and answers related to Kubernetes. Whether you are a seasoned professional or just starting out, these questions will help you prepare effectively for your next job interview. Gain insights into core concepts, best practices, and real-world applications of Kubernetes that employers often seek. 1. What is Kubernetes, and why is it popular today? Kubernetes is an open-source container orchestration platform designed for automating deployment, scaling, and management of containerized applications. Its popularity today is driven by its ability to simplify the complexities of managing containerized environments, especially in microservices architectures. Kubernetes provides features such as self-healing, load balancing, and automated rollouts and rollbacks. Its flexibility in supporting various cloud providers and on-premise solutions makes it an attractive choice for organizations looking to enhance their DevOps practices and improve application resilience. 2. Can you explain the architecture of Kubernetes and its key components? Kubernetes architecture consists of a master node and multiple worker nodes. The master node controls the cluster, managing the API server, scheduler, controller manager, and etcd for persistent storage. Worker nodes run the containerized applications, with each node containing a kubelet, which communicates with the master, and a container runtime like Docker. Key components include pods, which are the smallest deployable units, replica sets for scaling, deployments for managing updates, and services that provide stable networking. This architecture enables efficient orchestration of containerized applications. 3. What are pods and nodes in Kubernetes? Pods are the smallest deployable units in Kubernetes, representing a single instance of a running process in your cluster. Each pod contains one or more containers that share networking and storage resources. Nodes, on the other hand, are the physical or virtual machines that host the pods. Each node runs a kubelet, which communicates with the Kubernetes control plane, ensuring the pods are running as desired. Nodes can be managed individually, but Kubernetes abstracts their management, allowing for easy scaling and deployment of applications across the cluster. 4. What is etcd, and what role does it play within a Kubernetes cluster? etcd is a distributed key value store that serves as the primary data store for Kubernetes. It stores all cluster data, including configuration details, service discovery information, and the state of the cluster. etcd ensures consistency and availability of this data across nodes. It acts as the source of truth for the Kubernetes control plane, providing reliable storage that enables the orchestration of containerized applications. Any changes made in the cluster, such as scaling or updating resources, are reflected in etcd, allowing for seamless coordination and management of the entire Kubernetes environment. 5. What is the connection between Kubernetes and Docker? Kubernetes and Docker are complementary technologies. Docker is a containerization platform that allows developers to package applications and their dependencies into containers. Kubernetes, on the other hand, is an orchestration tool that manages the deployment, scaling, and operation of these containers. While Docker provides the environment to run containers, Kubernetes manages clusters of these containers across multiple hosts. This connection enables developers to efficiently build, deploy, and scale applications in a cloud-native environment, streamlining development processes and enhancing resource utilization. 6. How do you manage and configure Kubernetes clusters in a production environment? Managing and configuring Kubernetes clusters in a production environment involves several key practices. First, leverage infrastructure as code, IAC, tools like Terraform or Helm for consistent configuration management. Implement role-based access control, RBAC, to enforce security policies and ensure only authorized personnel can access resources. Regularly back up etcd data and use monitoring tools like Prometheus and Grafana for performance insights. Automate updates and scaling through continuous deployment, CD, pipelines, and utilize namespaces to isolate environments for development, testing, and production. Regular audits and compliance checks help maintain security and governance standards. 7. What strategies do you use for monitoring and logging in a Kubernetes environment? Effective monitoring and logging in a Kubernetes environment involve using tools like Prometheus for metrics collection and Grafana for visualization. Implementing centralized logging solutions, such as ELKstack, Elasticsearch, Logstash, Kibana, or Fluentd, allows for capturing logs from all pods and nodes. Setting up alerting mechanisms through tools like Alert Manager can help notify teams of abnormal behavior. Additionally, integrating tracing tools like Jaeger enhances observability, enabling better insights into application performance and behavior across microservices. A comprehensive strategy fosters a proactive, responsive approach to system reliability. 8. How do you handle secrets and configuration management in Kubernetes? Handling secrets and configuration management in Kubernetes involves using Kubernetes secrets and config maps. Secrets allow you to store sensitive information such as passwords, OAuth tokens, and SSH keys securely. They are base 64 encoded and can be mounted as environment variables or volumes in pods. Config maps, on the other hand, are used for non-sensitive configuration data, such as application settings. Both can be easily updated without redeploying applications. Tools like Helm and Customize can help manage configurations across environments effectively, ensuring that deployment is consistent and secure. 9. How do you automate Kubernetes deployments? Automating Kubernetes deployments can be achieved through several methods. One effective way is using continuous integration, continuous deployment, CI/CD, tools like Jenkins, GitLab CI, or Argo CD. These tools can monitor code repositories for changes and automatically trigger deployments. Helm, a package manager for Kubernetes, simplifies application deployment by managing Kubernetes manifests. Additionally, implementing GitOps practices allows you to manage Kubernetes resources directly from Git repositories. This ensures that any changes in Git are automatically synchronized with the Kubernetes cluster, enhancing deployment efficiency and consistency. 10. What are the differences between deployments, stateful sets, and daemon sets in Kubernetes? Deployments manage stateless applications, ensuring that a specified number of replicas are running at all times. They allow for easy updates and rollbacks, making them ideal for applications that can tolerate brief downtimes. Stateful sets, on the other hand, are designed for stateful applications, providing stable, unique network identifiers and persistent storage. They maintain the order of deployment and scaling, which is crucial for databases or distributed systems. Daemon sets ensure that a copy of a pod runs on each node, facilitating cluster-wide tasks such as logging or monitoring. Each serves distinct purposes based on application requirements. 11. What is a Kubernetes ingress and how is it used? A Kubernetes ingress is an API object that manages external access to services within a Kubernetes cluster. It acts as a reverse proxy, routing HTTP and HTTPS traffic from outside the cluster to the appropriate services based on defined rules. By using an ingress controller, you can implement features like SSL termination, URL path-based routing, and host-based routing. This allows for efficient traffic management and simplifies the configuration of load balancing, eliminating the need for exposing each service with a separate load balancer. 12. How do you approach scaling applications in Kubernetes? Scaling applications in Kubernetes typically involves using the horizontal pod autoscaler, HPA, which automatically adjusts the number of pods in response to observed CPU utilization or other select metrics. For manual scaling, applying the kubecl-scale command allows you to specify the number of replicas directly. Additionally, setting resource requests and limits ensures pods behave predictably under load. Implementing cluster autoscaler can dynamically adjust node counts based on pending pods. Effective monitoring tools provide insights into application performance, guiding scaling decisions. 13. What tools do you use for CI/CD in a Kubernetes environment and why? In a Kubernetes environment, tools such as Jenkins, GitLab CI, Argo CD, and Tekton are commonly used for CI/CD pipelines. Jenkins offers flexibility with plugins and supports diverse workflows. GitLab CI integrates seamlessly with version control, enabling efficient pipeline management. Argo CD is great for GitOps practices, allowing deployments directly from Git repositories, ensuring consistency. Tekton is a Kubernetes native framework that enables building CI/CD systems tailored for cloud-native applications. Each of these tools enhances automation, collaboration, and deployment efficiency, vital for modern development practices. 14. How do you manage resource requests and limits for containers in Kubernetes? Managing resource requests and limits for containers in Kubernetes is essential for ensuring efficient resource utilization and application stability. First, define resource requests to guarantee a certain amount of CPU and memory for each container, which helps the scheduler make informed decisions. Then, set limits to prevent containers from consuming excessive resources, avoiding potential disruptions. Implementing these settings in the pod specification allows Kubernetes to enforce them. Regular monitoring of resource usage using tools like Prometheus helps fine-tune these values based on application performance and behavior. 15. How do you handle versioning and rollbacks of applications deployed in Kubernetes? Versioning applications in Kubernetes involves using labels and annotations within your manifests to track versions. Employ a CI/CD pipeline that automatically tags images with version numbers. For rollbacks, utilize Kubernetes built-in deployment features. You can specify a previous revision to revert to using kubecl rollout undo deployment, less than deployment name greater than. This allows for quick recovery from issues with a new version. Additionally, implement health checks to ensure the application is functioning before fully deploying a new version. This strategy minimizes downtime and maintains application stability. 16. What are some best practices for writing Kubernetes manifests? When writing Kubernetes manifests, it is essential to ensure clarity and maintainability. Start by using descriptive names for resources, which helps with identification. Utilize labels and annotations effectively to organize and manage objects. Always specify resource requests and limits to prevent resource contention. Use version control for your manifests, allowing easy tracking of changes. Finally, keep your manifests modular. Break them into smaller files or use templates for reusability. This approach simplifies updates and enhances collaboration among team members. 17. How do you implement network policies in Kubernetes to secure communication between pods? Network policies in Kubernetes can be implemented using YAML manifests that define the rules for pod-to-pod communication. To secure communication, first, create a network policy resource specifying the pod selectors and namespaces. Define ingress and egress rules to control traffic. For instance, you can restrict access to specific pods based on labels or namespaces. Ensure that your cluster supports network policies by using a compatible CNI plugin. By applying these policies, you can enforce security boundaries, allowing only authorized traffic and enhancing the overall security posture of your Kubernetes environment. 18. How do you approach security in a Kubernetes environment? In a Kubernetes environment, security involves multiple layers. First, implement role-based access control, RBAC, to limit user permissions and access to resources. Additionally, network policies should be established to control traffic between pods, minimizing exposure. Securing sensitive data through secrets management is essential, ensuring that secrets are stored securely and accessed only by authorized pods. Regular vulnerability scanning of container images is crucial, along with using trusted registries. Lastly, keep Kubernetes and its components regularly updated to protect against known vulnerabilities. 19. How do you handle secrets management in Kubernetes? Secrets management in Kubernetes involves using the built-in secrets resource, which stores sensitive data such as passwords, OAuth tokens, and SSH keys. To handle secrets, you can create a secret object that can be referenced by your pods. This enables you to inject sensitive information directly into the application environment without hardcoding it into your source code. Tools like HashiCorp Vault or AWS Secrets Manager can also be integrated with Kubernetes for enhanced security, enabling dynamic secret generation and auditing capabilities. Additionally, implementing RBAC in network policies helps ensure that secrets are accessed only by authorized entities. 20. How do you ensure compliance and governance in a Kubernetes deployment? Ensuring compliance and governance in a Kubernetes deployment involves several key practices. First, implement role-based access control, RBAC, to restrict user permissions based on their roles. Regular audits and assessments of configurations help identify any deviations from compliance standards. Utilize tools like Kubernetes admission controllers to enforce policies at the time of resource creation. Integrating security policies with CI/CD pipelines ensures that only compliant code is deployed. Lastly, maintaining up-to-date documentation and conducting training sessions for team members fosters awareness of compliance requirements and best practices. 21. Can you describe the process of troubleshooting a failing pod in Kubernetes? To troubleshoot a failing pod in Kubernetes, start by checking the pod's status with kubectl get pods. If the pod is in a crash loop, use kubectl describe pod less than pod name greater than to view events and error messages. Look for logs using kubectl logs less than pod name greater than to gather insights on what went wrong. If the pod is unable to start, examine the container's configuration, such as image availability and environment variables. Checking resource limits is also essential. If issues persist, consider investigating node conditions and network configurations that may affect pod communication. 22. Can you discuss a challenging issue you faced while working with Kubernetes and how you resolved it? One challenging issue I encountered involved a persistent volume claim, PVC, failing to bind to a persistent volume, PV. This situation arose because the storage class specified in the PVC did not match any available PV. To resolve this, I first checked the storage class and confirmed its settings. Next, I created a compatible PV and ensured the capacity matched the P versus C's request. After implementing these changes, I monitored the PVC status until it successfully bound. This experience deepened my understanding of Kubernetes storage management and resource provisioning. 23. What is your experience with Kubernetes operators and their use cases? Kubernetes operators are powerful tools for managing complex applications on Kubernetes. They extend Kubernetes capabilities by using custom resources and controllers to automate application lifecycle management. My experience includes deploying operators for stateful applications, such as databases and message queues. These operators monitor application health, perform backups, and manage scaling based on demand. Implementing operators has streamlined deployment processes and reduced manual intervention, leading to increased reliability and quicker recovery from failures. Working with operators has enhanced my understanding of Kubernetes extensibility and operational efficiency. 24. How do you manage multi-cluster Kubernetes environments? Managing multi-cluster Kubernetes environments involves several strategies to ensure consistency, security, and efficient resource utilization. First, a centralized management tool like Rancher or OpenShift can simplify operations across clusters. Implementing GitOps practices helps maintain consistent configurations through version control. Networking solutions such as Istio or Linkerd facilitate communication between clusters. Additionally, using tools like Argo CD for continuous deployment can streamline updates across environments. Monitoring and logging must be centralized, leveraging tools like Prometheus and Grafana to provide visibility into all clusters. Security policies and access controls should be consistently applied across clusters to ensure compliance. 25. What is your experience with service meshes, and how do they integrate with Kubernetes? Service meshes provide a way to manage microservices communication within a Kubernetes environment. My experience includes implementing Istio and Linkerd to manage traffic, enhance security, and provide observability. With service meshes, you can control traffic routing, enforce policies, and manage service-to-service authentication seamlessly. Integration with Kubernetes is straightforward, as service meshes leverage Kubernetes' native resource definitions for configuration. The sidecar pattern is commonly used, allowing services to operate without changing their codebase, thus facilitating resilience and performance improvements in microservices architectures. In this video, we've explored the top 25 Kubernetes interview questions and answers that will help you prepare for your next job opportunity in cloud-native technologies. Mastering these concepts will not only boost your confidence but also enhance your understanding of Kubernetes, making you a valuable asset in the tech industry. If you found this information helpful, please give us a thumbs up and share your thoughts in the comments. Don't forget to subscribe to our channel for more insightful content and to stay updated on the latest trends in technology. Thank you for watching.